Hello and welcome to today's session, which serves as a sneak peek into the role of data and AI in driving business growth and innovation. We will be discussing this and several other topics with our panel of distinguished speakers on October 20th at the Latent View Analytics Roundtable in Menlo Park. I'm delighted today for today's session. We have one of our esteemed panelists, Mr. Jose Abelenda, with an illustrious career spanning over 2 decades in the areas of analytics and data science. Jose currently holds the position of Director of Data Science at Lyft. Throughout his impressive journey, he has spearheaded several analytics and data science initiatives in renowned organizations such as PayPal, Hotwire, JP Morgan Chase. Jose, we are thrilled to have you here for the session and looking forward to gaining valuable insights from your extensive experience. Welcome, Jose.
Thank you for having me. I should have you work on my resume. I should not be ever wanting for a job with that sort of presentation. I did that well myself. So
Yeah, no, there is a lot to talk about your resume, but yeah, I think in the interest of time, we have just restricted you to that. So, Jose, to begin our conversation, I would like to just touch upon. I know that you have had several experiences using data science, AI, in leading several transformation journeys across organizations. Anything that stands out where the use of data, AI actually transformed the operations and gave you multiple gains in any industry domain or any client or work that you did?
Yeah, totally. I mean, let me tell you about sort of a couple of examples. Yeah, and just in terms of machine learning, just being foundational, just enabling a business model to begin with. So at PayPal, fraud. Fraud is like the fundamental data science problem to solve, like it's in a payment network. And you can imagine that in the early wild days of the internet, it was even more an issue. And so, while I personally did not work on sort of fraud detection at PayPal, I think it makes a good example of a technology and an ML, an application of ML that is just completely foundational, makes an entire sort of company, in fact, in some sense, an industry possible. If you think of PayPal as being a company that essentially, together with eBay, like at the time, but makes a much smaller online firm size possible. It makes it basically possible to have like much smaller sort of online retailers. It's just really a foundational technology. Now at Lyft, which is where I currently work, just to give you one example, there are many applications of machine learning, but to give you an example of like a foundational pure machine learning, pure prediction technique, you have the estimation of travel time. Right, so estimating ETAs, like assuming that you know where riders and drivers are, which again is GPS pings and a Kalman filter. So talking about old technology, but it works well, right? So it's useful. But once you have these locations, literally everything that you do, whether it's computing a price or deciding within the dispatch system who goes to pick up whom, it's impossible to do that without an estimation of travel time. And so that machine learning application is completely you wouldn't have a rideshare marketplace if you can't compute ETAs. So that's an example of something that's foundational. Now, in terms of something that's been very transformative for Lyft, I said like the whole field of meta learners, so of causal machine learning, have the estimating heterogeneous treatment effect. That has been extremely important for us. Like it's whether you're thinking about pricing as a problem. So pricing a ride, although you can think of it as a prediction problem, it is fundamentally a causal problem. Like how will conversion depend on the level of price? That's really sort of a causal question that you ask. You're trying to basically estimate a demand curve. Lyft and Uber, because there's that company with the black hat we should talk about. Right? So we both decided we can have an open marketplace, you can have an open platform. Riders and drivers can come in and out as they please. The way you control the marketplace is through incentives, through like pricing, rider pricing, driver incentives, coupons, discounts. And so determining what is the impact of offering somebody a higher price for a ride, or what is the impact of offering a discount, a coupon. providing incentives to drivers move their driving behavior at all? Does it make it more compliant? Do they drive more? Do they drive more when you need them? These are also fundamentally causal questions. I think where you essentially, what you're trying to do is trying to estimate almost individual level differences in potential outcomes. So that is give you a sense of the level of ambition of what you're trying to do. I'm always baffled by how well these models actually work, right? So I have all the noise and all the trouble, but building these models for us has been sort of a game changer in terms of actually being able to control the marketplace and to offer incentives that at a level of cost that won't break the bank. Right? So making this financially viable, basically.
Right. No, Jose, very true. And I guess you touched upon very interesting, like two of the topics which span across industries, right? Both fraud and risk, as well as pricing. How do you price it right, depending upon the consumer type and the type of offers, discounts. And across industries, we have seen like organizations are trying different means to leverage data, to leverage AI to get as close to possible to have the decision making. Jose, we will continue. We'll just take, I know, in the short span of the session that we have, one slight diversion, not exactly a diversion of sorts, but we've seen like the large language models and the leap that AI is taking in the recent times. With that coming in, how do you see the interaction between the human capital that we have, the advancements in the AI technologies, as well as the data that is needed to fuel all these AI advancements? How is the role going to change, or what does the future look like? Any thoughts around that?
Let me give you like sort of in very much in a Lyft context. Let me tell you what the opportunity I think is for Lyft and for Uber, by the way. So, and probably for other companies, but just stay local. The one thing that's missing for us right now in terms of the richness of our data set is intent. So we have a lot of geolocation data, we have a lot of time data. There's a lot that we can tell about whether our customers are price sensitive or time sensitive. There's some things that we can tell about context. But the reality is that when you order a ride, we don't know why you're ordering that ride. We can take some guesses. Right? If you're taking a ride from Richmond to downtown San Francisco at 8 o'clock in the morning, chances are you're going to work, right? So it's a reasonable guess. But the truth of the matter is that we don't know. We do believe that if you had the ability to interact with customers and have customers relate to you their intent, that you could customize the product much better for them. And there's a lot more that we could understand about price sensitivity, about like sensitivity across modes, about if they provide you with a good or a poor experience, like where you're really time constrained. So there's a lot that we could do if we had that information. The issue is that right now we don't have a product interface to extract that information. So we do get text from our users, but it's usually when things have gone sideways already. So they're complaining about their coupon not working, or not getting paid enough, or like the rider or the driver doing something. Like sometimes they're like slinging mud at each other. So there's lots of data when it comes to like things going sideways, but we don't have a lot about when it comes to pure intent. So assuming that we could build the interfaces to extract that sort of intent. So imagine ordering your ride through a chatbot. Not so practical, but if you could build that technology, then now all of a sudden you would have a great deal of information that you could extract, directly through a language model, through the type of language that's the sort of lexicon that's being used, and what people are revealing about their intent, but even their level of frustration when they're talking to the app. If amplitude is going up and frequency is going up, the chances are you're annoying people. So that would be useful information to have. So I think that has sort of potentially a great opportunity, assuming that again we have the skill, the ability to build an interface that the users would actually want to use to do that. The other thing that I do see coming, it's coming slow, but I think that people are sort of working on it, is the other big opportunity is a lot of standardization and sort of improvement in productivity in sort of interrogating databases, right? So It's just something that's been said like a million times in I don't know how many sort of big data or Hadoop or whatever sort of Snowflake
Right.
meetups. We have
Yeah.
great technology, great relational and non-relational like NoSQL and high-speed column databases. So there's all the technology around the storing, the retrieval, the manipulation of data. But
Mhm.
when it comes to it, at the end of it, there's like thousands and thousands of hours of programming of people sitting in
Sure.
front of like me and you sitting in front of like a computer
Yeah.
screen typing out code to try to get
Right.
like something useful out of it, something that a product manager, a business manager can use out of a database. There's like
Sure.
thousands, millions of hours worth of programming. They're still needed, necessary to get information. And I think the
Right.
question is like, do language models, do
Mhm.
applications built on top of language models eventually become sort of a force multiplier where a lot of this work can, the productivity of a data scientist can substantially be increased. Does it mean that we're going to
Right.
go out of business? Maybe. So
Yeah.
that's not
Yeah.
in mind. But I think that
Right.
that's another area where the standardization of code, a first layer of producing sort of basically boilerplate sort of SQL for 90% of the questions,
Mhm.
style, effectively enforcing style guides without having sort of an expensive K6 read through SQL for like 20 hours a day.
Yep. Yep.
All
Yep.
these things, or Python code, or R, or Julia, whatever it is that you're using, right? So, right, the,
Right.
the beauty is that language models are pretty open about like different dialects. Maybe they're going to be the last thing that could read Fortran like 10 years from now. So,
Yep. Yep.
somebody might have to like fix an old Fortran library and just give it to a
For
language
sure.
model and see what
Yep.
happens. So, yeah,
Yep.
yeah. So those are
No,
the two areas where I think like this is where this is coming for Lyft at least.
no, totally, Jose. And I think the work has already started. I keep reading articles where like making it for the non-users as well to interact with a lot of data that is at the back end, and how language models can interact even with the coding part of it, right? So different languages, as you mentioned.
That's right.
And yeah, like some exciting times ahead of us to see how this evolves and how
But exciting and scary.
folks interact.
So,
For sure, in the realms of like what we can do. Yep,
yeah.
for sure. Yep. Now, looking forward to taking this to the next step and discussing in detail along with our other panelists on October 20th as part of the Latent View Analytics Roundtable in Menlo Park. Thank you so much, Jose, for your insights and inputs, and love to take this conversation deeper in our next session as part of the roundtable. Thank you so much.
Thank you for having me. Very much looking forward to the conference and see like what kind of interesting conversations we're going to have.
For sure. Yep. Have a great one. Thank you.
Cheers.